Okay, so what I'm going to do now is I'm going to talk about several applications. And before that, I'll talk a little bit about the choice of instruments. So before we said, okay, here's the analysis that we do conditional halving instruments. And now I'll kind of give you some examples of what the literature has used, kind of to talk both kind of the pluses and minuses of these instruments. And then we'll go specifically talk about 3 different papers where we'll look at exactly what they did and look at some of the numbers and talk about the instruments through that. And I think that would be a great time to kind of raise various questions and issues of how one can deal with. So the papers I'm going to talk about is the original, the BLP paper, looking demands for autos. Then a paper by Penny Goldberg in the same issue of Econometrica. And then I'll talk about some of my own work on breakfast cereals. Okay, so I said some of this. We basically talked about the estimation conditional and halving instruments, and then we'll talk about where these instruments come from and see several applications. So before talking about instruments, let me just sort of emphasize, this was, I said this before, but I want to emphasize again that instruments here, or the moments, actually have dual roles here. And one is we actually need to generate moment conditions to identify the nonlinear parameters. And the other is to deal with the correlations between prices and the error term. Okay, so let me actually show specifically kind of a specific example in the case of the nested logit. So nested logit, remember we were saying that there's a couple of examples where we can actually do the inversion analytically. So we saw what it looks like in the logit. The nested logit, which is just a, I'll talk a little bit more about it later, but it's basically what you do is you separate the products and put them in nests or in segments, and you create sort of a correlation structure. You say there's a nest-wide shock, right? And then there's still this epsilon IID shock, right? And that's going to create kind of this particular, and you put a particular distribution on the common shock, and that's going to give the nested logit. Well, in the nested logit, what you have is you have exactly the same as in the logit. So you have this xjt beta, alpha pjt, and psi, right? Exactly what we had in the logit, plus this additional term, which is just the log of the within segment share, right? So this is the share of product J within the segment G or group G. Okay, so that's the difference, right? So unlike the logit where there's no nonlinear parameters, no heterogeneity, here there's one. Here, which basically tells you if you want the relative importance of the variance of the kind of the nest shock, right? That's what this row is. So in this case, suppose for example the p's and the x's were completely exogenous, completely independent of psi. Okay, so if we didn't have this term, we could just estimate this with OLS, right? But once we have this term, right, we could assume it's independent, but that wouldn't make sense because remember in here we have the share, right, as we do here, right? So this is the share relative to the outside good, and this is the share relative to the share of the segment, right? So if you get a high psi, right, it's going to impact your share within the segment, right? And unless it's a very, very special case, right? But in general, it's going to impact, right? So this is kind of, if you want, it's kind of a correlation that we really can't get away from, right? It's not just sort of saying, oh, well, prices were determined, kind of were preset, right? Or were determined by some experiment. I mean, it's almost impossible to think of, okay, when would this not be correlated with the error term, right? And therefore, we need an instrument for this term, right? Even if prices and characteristics were varying randomly, okay? So that's kind of this, what I call kind of the second rule, and it's very easy to see in this case because we can write out what this, what the delta is, right? But in general, right, in the general random coefficients model, we can't write out the delta, but it's exactly the same type of problem, is the fact that we need some sort of a moment condition to identify the parameters, the nonlinear parameters. Okay, and we can't just use nonlinear least squares. Here it would be linear least squares because exactly this problem that what we'd have is the derivatives that nonlinear least squares would actually have shares in them, right? And therefore endogenous terms, right? I mean that's kind of another way of saying this. Okay, so what we need is, right, we need instruments for the nonlinear terms. Now, price endogeneity, interestingly, which is a lot of the motivation that we want, a lot of times we can actually handle it in other ways not using instruments, and we'll see some of that. And that's basically, especially if we have kind of repeated panel, if we want to put some structure on this, sometimes we could put enough structure on it to say, well, whatever residual variance is left in prices, that's exogenous, right? So you could say, well, suppose we have repeated observations of shares, maybe we could put a product fixed effect to capture the unobserved product quality, and whatever is left over, maybe that is exogenous for the price endogeneity. And we'll see kind of examples of that. Okay? So with that in mind, let's go and see what people have actually used. So let me start with what I think is by far the most commonly used instrument, which is to look at competition in characteristic space. So the assumption is the following. We're going to assume that the expected value of xi, the unobserved characteristics, is mean independent of the observed characteristics. And this is here, it's maybe hard to see, but the x is boldface, so it's actually the vector or matrix of all the characteristics of all the products in the market. Right? So we're saying all the observed characteristics are mean independent of the unobserved characteristics. Okay, and we'll talk in a second kind of, what that means or what we think about that. But then the basic idea is we're going to use these as instruments, or we're going to use that to generate moment conditions. And there's different ways of implementing this, and partly we actually now suddenly go from maybe not having an instrument to now we have actually an embarrassment of riches, right? Because now remember, if there's k different characteristics and j different products, so we have j times k potential instruments, right? So it's a lot of instruments, although we think that maybe the identifying power of any marginal one is small, so we need to somehow maybe find a way to use this. So BLP proposed using the following. They proposed to basically use your own characteristics, right? Which, again, if you kind of look at this equation, you can think of, saying, okay, you're going to use them as, they're already in here, right? So you want to use them as instruments anyway. So the own characteristics of the product. You want to use the sum or the average of the characteristics of the other products produced by the firm, right? So if you're General Motors, you look for each product its own characteristics and then the average characteristics produced by it. And then you want to use the sum or the average of the characteristics computed by competitors. Okay? So that's what they propose using. Well, what's the basic idea, or what's kind of the power of these instruments? The idea is that basically if the proximity in characteristic space to other products is going to impact your markup, which in turn is going to impact the price, right? So if we think that basically price is equal to marginal cost plus markup, generally speaking, if you want an instrument, you could say, okay, I'm going to look for something exogenous that's going to impact cost, or I'm going to look for something exogenous that's going to impact markup. These instruments try to work through the markup term, okay? And the reason to separate these, right, is to basically say, well, my markup term is going to react differently whether it's my own products, right, or the product of competition, right? And that's kind of, intuitively it's trying to kind of bring in, let's kind of try to bring in the I/O and have a particular functional form of how these work. The validity, right, we need these to be exogenous. So the way that we usually set, we think about this to say, well, these characteristics, so if you think again of the auto market, you think these are the characteristics actually set quite a while in advance, right? So if you kind of think, well, these are set before the firm actually knows xi jt, that's usually the argument that people give to justify why observed characteristics are mean independent of unobserved ones. Now, I'm sure at this point your kind of mind is raising and saying, well, wait a second, but can we come up with stories that will make these invalid? And the answer is it's not very hard to come up. So even if you don't know exactly the xi, you might say, well, you have some expectations about what it would be. So you want to separate between the part of xi that's known when they set and one that's sort of shown up later. And we'll get back to kind of, if you want a modified version of this that tries to do exactly that. Yes? Well, because if you think of, so think of my pricing problem, right? So suppose, let's think of, I have a firm, I have two products, okay? So I have product A, product B, and then there's a product C that's produced by a manufacturer, a competitor. Now, think of different markets where that products B and C are located in characteristic space vary, right? And think of how my pricing will respond to it, right? So that's essentially what we're trying to pick up here, right? Is as you move across markets, the competition is going to vary, therefore impacting your markup. And the way in which your markup will vary depends on whether it's your own product or your competitor's product, right? So for example, if it's your own product that's close to you, we tend to think that will increase your markup, okay? Or many models will deliver that, okay? Yet if it's your competitor that's close to you, that would decrease your markup, okay? So that's the reason you want to separate between, well, I guess that's the reason why both of these might actually have some validity, might have some power, right? And why you want to separate them, because they'll actually work in different ways, right? So if product B is owned by my competitor or owned by me, product B being the one closer to me, my pricing incentives are very different, right? And that's what we're trying to pick up. And then what we want to say is, let's say when we look over markets or over time as the relative difference, right? So there's always product B and a C, but how far or close they are in characteristic space, that's going to vary. And we want to see that variation is going to impact the price, right? So as long as, where they are, their location in characteristic space is, satisfies that condition, you think, that would be a valid instrument. Okay, does that answer the? Yes.
So shouldn't then the price of the competition or the same company product, I mean, the instrument should be lag of that, because again, the current prices might be then again endogenous.
No, we're not using, these are not prices. Here the X's are just the characteristics of other. We don't use the prices, because the prices of everyone are determined in equilibrium, right? So what we're using here, these are, let me just, this is where my notation is slightly different than Ariel's. Here the X's are just the observed characteristics excluding price. Okay, so we're going to assume that the characteristics, the observed characteristics, are actually independent, but price is allowed to be correlated, right? So price basically, so if you want to think the timing here is that, you first set the X's, right? Then psi is revealed, and then you set prices. Okay? In a game where you're setting your prices as a function of everyone's size and everyone's prices. Okay, so that's important. Chris, was there?
It just seems like we're trying to get at proximity and try to fix the sum. It's a strange way of getting at that.
Yeah, I mean, I think of it, since there's also a constant, just a number, I mean, it's basically like the average.
Right, so the average, whatever, but I mean, you can come up,
No, you can.
A sedan is competing against a sedan in one market versus Yugo and the
No, you can.
same average.
You can, and then the question is really, it's just really a question of, we have a lot of these X's, and what's kind of a reasonable approximation to it? Because we know we want some function of the X's of the other X's, and the question is what function, and I don't think this is completely unreasonable. I mean, in the sense of, for the reasons I just said. Now you might say you want to separate this, or you might want to allow it, if you think of a, let me use, first stage, although it's very misleading, but if you actually thought of a first stage here, you could say allow for different first stage for different parts of this, right? So you might say how much I, react to these would be different in the, different segments of the market, okay? But that's just another way of saying that you want interaction maybe between, these things and the own characteristic, right? Which segment is one of the own characteristics. So you can obviously sort of do more, and if your data you feel that it's justified, you can do that. But this is kind of, if you want, sort of the simplest version, and one that's kind of often used. So kind of just going on to this point, these are probably the most commonly used instruments, and they're most commonly used for a lot of reasons. But I think one of the reasons is the fact that they really don't require any additional data that we don't already have, right? Because these characteristics, we already need them for the demand. Right? So it's not like we have to go and sort of find something and say, okay, in some sense it's kind of it's easy to use. These are often called, you'll see people refer to them as the BLP instruments, sometimes literally kind of by those terms. And I mean, you can ask Ariel sort of during the break, but I think that's, that's kind of doing a little bit of injustice to, we'll talk about the BLP paper later. BLP do use these instruments, but they actually also use other instruments. So these are a subset of the total BLP instruments, and it's actually not quite clear, we'll talk about it, as to where they're actually getting their identifying power. It might actually be more from the cost side instruments, which we'll talk about next.
Are you going to talk a little more about the validity bullet there? About
Not much more than what I wrote here, and not much more than saying that, yeah, I mean, let me just say a general point that I actually should have said when we started. So I ended the previous lecture saying, oh, a lot of people have, put time in computation, and, I think I kind of, said at the end it's not quite clear that it matters that much, right? If we're talking about 15 minutes versus 30 minutes or whatever. Where I do really think that we need a lot of work, or where, our kind of weakness are in these models, are in the instruments. Both in terms of, it's hard for me now, I mean, even though I'm telling you what we'll talk about specifically in specific examples, but both in terms of their validity and also in terms of their power. There's been a little bit of work recently of kind of whether these instruments are weak for some things, but we generally need much more work on it.
I just don't understand the logic. You're saying the observed characteristics are assumed, you're assuming they're set in time before the unobserved
Characteristics is revealed to the firm.
to the firm.
Yes.
But some of the unobserved characteristics are, I think Ario was using the example of the Lincoln and the little gizmos inside. Well, obviously that's not true.
Yep.
Right? You're not going to argue that.
Well, yes, I agree. I mean, depends on the situation, but that's the assumption here is that this is. I mean, I think the easiest way to rationalize is to say that these are characteristics that are actually set before the firm gets to see. Now, of course, what these unobserved characteristics are depend on the application. Okay, so I'm kind of building up, but I'm sort of telling you this is kind of the way. This is the assumption that's often used, and it's easier to defend in some cases than in others. Okay. Oh, yep.
I believe the validity, couldn't I still use instrument sets 2 and 3? In other words, that validity is only for the first bullet point.
Well, I mean, I guess I wrote it sort of all together, and you could sort of say, well, in that case, what you need is, right, you'd also need, if kind of going back to kind of looking at this, you'd also need instruments, for this particular first part. But it's also the question of what does the firm know? So you could say, well, it doesn't know its own, it knows its own characteristics, but doesn't know the others. So yes, you could sort of refine this a little bit further and say I'm going to use, right, but it's, again, the question, and 2, again, it's something that the firm said. So if you literally think the firm is sitting there determining both the X's and the X's at the same time, it's going to do it for all its products, right? So probably 2 is going to be it. Now, the competitors, you could say maybe, but then you're walking on a little bit of a, right, of exactly what the information is, right? I mean, do you want to have, some game of imperfect information? I mean, it's, yeah. So anyway, I mean, it is what it is. I mean, it's, yeah. Okay. Other type of instruments, so I'd say the second most used instruments are what I would call cost-based instruments. So cost data, if you followed I/O, I don't know, anything in the last 25 years, we don't like to assume that cost data are actually observed. For instruments, we don't need to have the actual cost data, but some proxies to it. But even then, that's rarely observed. But there are ways to kind of get at this. So the other part of the BLP instruments is to use characteristics. So BLP actually, and we'll see it in a little bit, they're going to have the demand side, but then also specify a kind of an hedonic cost function, right? So there's going to be marginal cost that's going to be a function of characteristics, right? So there's going to be characteristics there as well. And what they use implicitly in their setup is they're going to use characteristics that enter the cost side, but not the demand side, right? So it's again going to be these type of characteristics of the products, but things that you don't think enter the demand, only the cost side, right? And we'll talk a little bit about later. I mean, you can't see from the final papers which matter more, but it seems like these instruments might actually be more important for driving the end results, and in some sense that's actually missed because a lot of what sort of followed just used these, the previous page, not these. So that's one set of cost instruments. Sofia Villas-Boas, an ex-student of mine, was actually estimated demand for yogurt. And what she went there and she actually got price of inputs, the various inputs of, that go into yogurt. The problem is that those are not going to vary by brand, right? So the question is, how do you get kind of variation across the different brands? And what she did was she basically interacted those with product dummies, right? And the idea is that there's some sort of production. Think of each brand has a slightly different proportions of using these inputs, but you don't actually know them, right? So you're trying to estimate in some sense what proportion they're trying to do. So that's again kind of a cost-based. Other instruments that try to indirectly get at cost measures are instruments that Jerry Hausman introduced, and we'll talk actually about, we'll see it, one of the papers where he used that tomorrow, in which I use, and we'll see kind of that application later. And these we're going to try to rely on indirect measures of cost. So here what we're going to do is something that at first sounds like a non-starter, and what we're going to do is we're going to use prices as instrument for prices, okay? But we're going to use prices in other markets. Okay, so the idea is you think of, suppose we have a cross-section of markets, okay? We might have a panel, but at any given time we'd have a cross-section of markets of the price, of the same good in a bunch of other markets. And we're going to use, I don't know, suppose we're estimating demand, and this is going to be both in the context of cereal. Suppose we're estimating demand for cereal in Boston, okay? We're going to use the price of cereal let's say, in Portland, Maine, as an instrument for Boston, right? So that's the idea. We're using prices of the same product in another market. So what's kind of the validity argument here? The validity is that after we've controlled for common effects, so we obviously have to control for common effects. So it could be, for example, if we look at Cheerios, right? Cheerios is popular in Boston and it's popular in Portland, Maine. Right? So we want to control, if you want, for a general kind of a cereal dummy, if you want. But after controlling for those common effects, whether it's just a Cheerios brand name or some advertising effect, what we're assuming is that whatever is left over, right? Whatever is left over in the Xi after we've controlled for all these things, they're independent across markets. So if you think about it, and that's the case is going to be in that application, suppose it's like just local promotions activities. And suppose that those are uncorrelated, right? There's a different brand manager in each one of these markets, right? And they're not coordinating their activities. So under that assumption, you say, okay, that's going to be independent, and therefore it's going to be a valid instrument. How is it going to have any power? Well, it's going to have power because you're going to assume that there's common marginal costs that are impacting everything, right? So again, after controlling for everything, we're going to say, well, there's whatever is left over is due to kind of common marginal cost and not because of shocks in the demand. Yes.
Where would a researcher go to get this kind of variation? I know that for labor prices, if you have a geographic study that you're doing, the BLS does have area-specific wages. So, but just in general, where can you go to get this sort of thing off the internet, sitting in your room, your computer there, without having to go to DP or go inside the Census Bureau? What's the advice on finding these?
Well, so for these types of instruments, actually, they have, if you have the right data structure, namely if you have a panel, a cross-section, if you have a cross-section across different markets, that's going to be just like the previous set of instruments, that's going to be in your data anyway, right? Because you have data, quantity and price data for Portland, and you have it for Boston, and then you can, cross-reference it. For the first part, I mean, that really depends. I mean, I know, Sophia, when she did this, she went and constructed some, some data for, I mean, obviously milk goes into yogurt. I forget what other inputs she used, but she actually went and collected some general, price series for that. And the main problem she had was that there isn't, variation either regional or by brand. So you somehow have to kind of generate that. So for BLS, I mean, we'll see it a little bit later when we talk about my paper. I actually did use some wage structure by market, but I'm actually now forgetting even where I got that. I should, it's been 15 years, so I forget exactly where I got it. But I think it was actually some bureau, I think the bureau actually had a database where I got that from, but I have to go back and read that up. I think it, yeah. I think that, but yeah, but I did get that somewhere there, but it's, so anyway, so that's kind of the arguments for it. Now, it's easy to come up with examples where these instruments, will not be valid. So for example, I say, well, suppose the brand managers are not coordinating, but you say, well, suppose there's actually regional brand managers, right? So whoever determines the prices, the promotional activities for these brands determines it for Portland and for Boston jointly, right? In that case, you actually would lose the validity, right? So that's one example. Another example is, suppose, again, you're estimating demand for cereal, and suppose in the middle of your sample, suddenly there's a study that comes out that said, fiber-rich cereals are healthy for you. Okay? So that's going to be a national shock to all markets. Right? Now, in principle, if you know that, you might actually be able to control for it. But if you don't, right, if that's what's giving you kind of the variation, and what you're using here is some sort of independence over time, that's potentially going to create correlation and make the instruments not valid. Okay? But once again, I'm telling you, these are what people have assumed and what they've used. And we'll see how you can actually try to address whether they're valid or not. The other commonly used instruments, or actually becoming common, they're not as commonly used, is to, again, rely on kind of panel data techniques. And the most obvious thing is just say, well, let's put enough fixed effects in there to maybe absorb all the endogenous variation, whatever is left over. We don't have to worry about price variation. We still have to get instruments for the nonlinear terms, but maybe we can sort of do that. At least to kind of not worry about price variation. And to some extent, maybe that's what you can think of the previous example. What you show is you put enough instruments in there, whatever's left over is roughly assumed independent. But the other way that people have generated instruments is to use the ideas from a dynamic panel literature. And this was actually originally, if you kind of look carefully at BLP, the original paper, it's kind of a footnote that said, one could use this. But I think at the time they didn't really think it would work, so they never actually experimented with it. But recently people have gone back to look at it. I'm not sure if this is the first paper that uses it, but it's the first that I'm aware of. So Andrew Sweeting actually has a paper where he brings this back, and basically what he assumes is he assumes the following. And this goes back a little bit to kind of these timing assumptions of when the x's are known and what's known what. So he says, suppose there's actually an AR1 process in the xi's. Okay, so xi today is rho times xi yesterday. Okay, and there's this kind of unexpected shock, right? So which we're going to assume that's uncorrelated with whatever the x's were. And here there's a little bit of a timing. You could say whether you want to use x's today or the x's at time at t minus 1, the characteristics at time t minus 1. But the whole idea is this is an unanticipated shock. Right? So there's a part of that you could say, okay, I know the xi's, at the same time period, but I'm trying to predict the future xi's. Well, if that's the case, then you can actually use kind of a pseudo or a quasi-differencing to create a moment condition, right? So the idea is that you're saying, it's not that I don't know the xi where I'm setting these x's, and again, it might be the lagged x's or the current x's, depending exactly on the timing you want to make here. It's not that I don't know. What I'm going to assume that I don't know is the kind of the innovation in this, right? So it's not as strong of an assumption as the one that you make in the original BLP, and you basically now say, okay, just in how to operationalize it, if you think of what we do later, it's just the same way that we computed the xi's. You compute xi t and xi t minus 1, and just create a moment condition based on this, right? You take this this quasi-difference between them, and that's kind of the basic idea. So Andrew's used it, and several other people have used it recently, and it actually seems to work reasonably well in terms of getting you estimates. Okay. Sorry? Yeah, and you'd estimate rho, again, it's part of the, you have enough x's in here that you can actually estimate. So rho becomes another parameter that you estimate. Yeah. Okay? So anyway, these are probably the most common instrument. There's occasional, you can see here and there people to try to use, some sort of, what labor economists like to call quasi-experiment or natural experiment, and try to use some sort of regulation change and stuff. And you see that here and there, but it's actually quite rare to see that in the literature. But with the exception of that, these are kind of the instruments that people have actually used. Okay, so what I want to do now is to go through, yes? you're asking me to give, well, partly because, I mean, it's a philosophical question that I'm sure I'll get into trouble for whatever I answer, but I think there's a difference in, I think that most I/O people, the way that they approach the problem is that you first start a market and then look for instruments, and you're going to end up with one of these things usually, as opposed to start with an instrument and say, okay, here's some regulation that we think is interesting and how can we use it, which is a lot of times the way that labor, at least some labor economists proceed, in which case I think you're going to end up maybe with an instrument that's better looking, but so I just think that's kind of just the nature of it, right? That we don't actually choose which markets to look at based on whether they're going to be good instruments or not, right? So we choose them for other reasons, and then we do the best we can. We maximize whatever we can in terms of the instrument, rather than first say, oh, let's find a place where there's really good exogenous variation and find something we can answer with that. I don't know, but so that might be kind of, if you want a theory of explaining why we ended at this, but I think just as a descriptive matter, I mean, I think that's where we are. I mean, these are the instruments that people have used, and I think it is because we start, I mean, I know from my own experience, I mean, I start usually saying, okay, this is the market I want to study. I go, look for the data. I find the data and, try to find an interesting question, try to write the model, and by the time you get to that, say, okay, what's the best instrument that I could use, as opposed to starting with the instruments and building up from there. But that's at least my experience. If anyone has a different experience, feel free to speak up. But, okay, so what I'm going to do now is I'm going to go through 3 different applications and show you kind of how all of this works together. So the first paper is the BLP paper, 95 in Econometrica, and 2 points that I want to take away from looking at this. So the first is just the effect of instruments. So right now, we've been doing this for a while now, right? I mean, it's what, almost 17 years since the paper was published, and even more since it was kind of doing the rounds. So I think we've also taken for granted the fact that, oh yeah, of course you need instruments. But originally that was something that needed proof. So I'll actually show you, the effect that instruments have, and we'll see that over and over again, at least in these 3 applications. But here we could literally put hundreds of examples. The other thing is to see again the difference between a logit model and random coefficient. So we talked about it in theory, but I'll actually show you numbers from their tables to show you the importance of allowing for the more general model. Okay, so the data that they use, they have 20 years of annual US national data, right? So a market for them is a year in the US, right? So there's 20 of these markets. Overall, they have just over 2,200 observations. Okay, an observation is a model year. There's an issue of how you define a model, and how they look at the quantity. So they define it by nameplate. The prices that they use are going to be list prices. Remember, we talked a little bit about the issue of, well, what happens if there's variation in it? For now, we're just going to look at list prices. There has been some follow-up work that asks, what happens, there's a paper I can think of that's done at an airlines. You can ask, well, what happens if there's variation in prices? How do we account for that? But for now, we're just going to ignore it. Characteristics is kind of a standard source, the Automotive News data book. I think you can actually get it in many libraries. And the pricing characteristics that they take are going to correspond to a base model. Because again, you could say there's different options or different trims, and which one do you use. And they're going to actually make very little use of either segment or origin data. Is it domestic or foreign car? And that's going to be important when we compare it to the next paper, the Goldberg paper. So the demand model is almost exactly the one that we've seen, with really one slight modification, which is before, really what we had, remember, was alpha times price. And really what we had, and I wasn't too careful in the notation, what we really had was yi minus price. So we just had income minus price, but income drops out because it's constant for all the options, right? So anything that's constant for all the options is just going to drop out. Right? And the discrete choice is basically, right, because all we care about is really the relative utility, so I didn't even bother putting it up. Now what they're going to have is they're going to have the log of yi minus p, and you can actually show that this would come out if you think that there's a Cobb-Douglas utility function, right, where you have kind of the numeraire and then the utility that you get from the car kind of feeding into a Cobb-Douglas, you get something of this sort. The linear, by the way, would come out if you have a quasi-linear utility function. Other than that, the random coefficients here on the x's, they're not going to have the demographics. They're just going to have this normal distribution. There's not, the alpha is not going to have a subscript I on it, but there is going to be heterogeneity in the marginal utility of income, basically through the log of income term here. Okay, and this is the utility from the option, from the outside good, right? But otherwise, it's basically the model that we had before. The estimation is basically as we discussed before, okay? What they do is they add supply side moments, okay? So what do I mean? I'm not actually going to go through it. What they do is they actually write down a particular pricing model. Ariel will talk a little bit more about this and the importance of it kind of in later lectures, but they're going to write down a pricing model. And that pricing model, it's going to be a marginal cost that's parameterized, a function of characteristics, and then a markup that's a function of the demand, right? So the pricing model is actually going to put some structure on the demand parameters, right? Because the markup enters into it, right? And so that's kind of the first point. It's going to help pin down the demand parameters, but it also, through the cost now, you can actually add cost instruments, right? So it's kind of both of these things, and it actually ends up that they're going to come. Both of these things are going to be quite important, right? So these are going to be the cost side instruments. These are characteristics of that enter only the cost and not the demand. And then on the demand side, it's these characteristics that we also talked about. The paper also spends a fair bit of time, and I think Ariel again might talk about some of these things about to trying to kind of make the estimates a lot more efficient. Things that I didn't really focus on, and I'm going to sort of skip now as well. All right, so let me just look at the numbers. So the first table that we have up here, this is estimates for the logit model. Okay, so remember the logit model here is just a simple linear regression, right? You're regressing the log of the odds ratio, right? The share of each share over the share of the outside good on these characteristics, right? So first they just do, this is just OLS, and then just linear IV. Okay, and the key thing that we want to focus on are basically actually these two rows here at the bottom. So we see this is price, right? And you can see here in terms of the magnitude, the price coefficient, more than doubles. It's almost 2.5 times larger in absolute value. Okay, so it actually takes it from being, and this is kind of the bottom here, you can see it takes it from being, if you look at the number of inelastic demands, you get about 1,500 inelastic demands out of 2,200 observations. So a huge fraction are inelastic under the least squares, to once you use the instrument, almost nothing, right? I mean, less than one, or about 1% are inelastic, right? Now remember, inelastic demand, I mean, not that they're going to use sort of the logit for it, but if we wanted to use the logit for this, would be quite problematic if you're going to, plug this into like a single product pricing. Okay, in some sense, you'd say that the predicted marginal costs are going to be negative. Okay, so this is, if you want the first point, you see just kind of this instrumenting makes a huge difference. Okay, now at this point you might say, oh, it's obvious. Of course we need to instrument, but you have to take this in the context of literature. Before that, people were estimating these discrete choice models without instrumenting for it. Okay, and we'll actually talk about an example of this tomorrow when we talk about welfare. One of the first papers that did this actually found an upward sloping demand curve, and a little bit hard to do welfare analysis when you get an upward sloping demand curve. But so that's kind of the first effect. Okay, the first thing to take. The second thing to take away from here is the effect of the random coefficients versus the logit. So let me kind of build up. I'll show you kind of a few numbers. Some of them I'll actually need a little bit later when I compare to another paper. So this is one of their tables that basically shows, if you want, own price elasticities. And let me just focus on the last column, which gives you the price. So what we have here is for each model, we have the first row is that's the price in thousands of dollars, right? So Mazda 323 is just over $5,000. The second row is the elasticity, okay, an absolute value. So the elasticity here is, is 6, and you can sort of see, the value for different products. Okay, so you can see the range here varies, from about 5 to 6 in terms of absolute value, and that's we'll kind of keep that, or we'll keep that in mind when we look at sort of the next paper at different numbers. How about the cross price elasticity? So one of the very first things, if you want to actually want to get estimates, want to ask yourself, are they reasonable, is to look at the patterns in the cross-price elasticity. So what we have here actually, these are semi-elasticities. So basically this is the percent change in the market share for a $1,000 change in price, right? So instead of a percentage change, it's $1,000 change. And the key thing I want you to kind of look at is if you look at the pattern within a column, okay? So if you actually wrote elasticities down, what you would get in a logit model, the elasticities, and we'll see some numbers, like, would be exactly the same. Okay, they would be identical when you go down the column. So one of the ways to see if you've gotten away from the logit model, and by the way, that's again, what Ariel was saying, if you don't get that, then you made a computational error somewhere. Okay, so what you want is to see if there's actually heterogeneity in these, and if that heterogeneity makes sense. Right? And if you look at these products, I mean, I'm not an expert on, on the car market in this time, but it sort of makes sense, right? So if you look at the Mazda 323, its closest substitutes are, the cars up here, and by the time you get down to the, the 735i, it's basically zero, right? So it makes, a very kind of clear pattern, and it's by orders of magnitude. Okay, in terms of the substitution. So you can see if there's a change in the price of these products, you can see it does almost nothing to the more expensive cars that are down here. Okay, yes?
Just a point of clarification, why, I have intuition for elasticity, I don't have very good intuition for semi-elasticity. When I read papers in literature, I very often see reported semi-elasticity, not elasticity. And why is that?
Well, there's actually, there is some intuition for why you want to do semi-elasticities, because with elasticities, in some sense, you're not keeping the quote-unquote experiment constant, right? Because you're changing a percent, it's a percent change in price, right? And what you want to say is you want to say, well, I want to do the same, experiment, the same variation across different columns, right? So I want to see what's the effect if I change by $1 or by $1,000 here, and I want to keep that constant across columns as opposed to say it's going to be a percentage, right? Because a percentage change, right? The Mazda was, 5,000, right? So a percentage change of 5,000 is very different than, one of these cars down here that's, almost 10 times more expensive, right? So that's the intuition. Now, which of these you want to look at? I mean, I don't know. I mean, I tend to prefer elasticities myself, but that's because a lot of the products that I look at, there isn't as much variation in the average price, right? So if I look at, consumer packaged goods, there's be variation between a generic and a national brand of, one is double the other, but it's not 10 times, right? But that's basically, I think, the intuition as to why you'd want to look at semi-elasticity as opposed to elasticity. Okay? But the key here, and that's kind of to keep in mind, is to really, remember how big this is, okay? Because we'll kind of look at sort of alternatives to this in a little bit. Okay, and then finally, to kind of bring home, the point of substitution to the of the difference between logit and random coefficients, this is a table that I think demonstrates very nicely, and that's the substitution to the outside good. Now, in the logit model, right? So this is off of logit. They're basically all 90%. Okay, I think the only reason they're not exactly just subject to some simulation or computational error. Okay, and the reason that what happens is when the price of a product increases, and some consumers decide not to purchase it, they're going to purchase, the outside good, or decide not to purchase the same frequency as the average consumer. Well, in this market, the market size defines such that there's a 90% share of people who don't buy cars. By the way, the market here is defined as the number of households in the U.S. Right? So in any given year, only about 10% of households buy cars. So if you're not going to purchase, regardless if you're not going to purchase a very expensive BMW or a cheap Mazda, you substitute with the same fraction to the outside good. Okay? That's in the logit. In the random coefficients, you see not only does, kind of the average changes, but it also kind of gives you, in some sense, kind of more reasonable patterns, right? So it's kind of more likely that if you're, the price of a BMW went up a little bit and you decide not to purchase a BMW, you're probably less likely to substitute the outside good. Now, you might ask, well, what is the outside good? Right? Now remember, that's the option of not buying a new car. Okay, so it's probably, if BMW went up a little bit, it's not to say, oh, I'm not going to buy a car at all, but you might substitute to buying a used BMW, right? That would be in the outside good as well. So that's why, maybe you wouldn't expect that to be 0, but you probably would expect it to be lower than what you would get for the higher, the cheaper cars. Okay? So that's just kind of one way of looking at the difference between them. There's other tables in the paper that show this. I'm not going to go over them. The final thing that I want to show you is the markups predicted. So you can actually take this, these elasticities and put them through a specific supply model. We'll actually see the supply model later, and then look at what the predicted markups are. And you get sort of these numbers here. Once again, I'm not an expert on this industry, but if you actually compare these to industry numbers, they're actually in the roughly kind of in the ballpark. Okay, so I think kind of the conventional kind of industry wisdom is that markup should be at about 15%, and that's kind of roughly where these things are. If you kind of average across the different products, I know Ariel might want to talk about it a little bit later, but I know that they actually compare this to what they actually I think show this to the car manufacturers, and they actually admitted, well, you guys kind of got it pretty much exactly right on. But again, I'm just kind of comparing. If you look to the public source, they're just kind of at least in the ballpark, in the right order of magnitude. Okay, and again, if you kind of did this either with Logit, you wouldn't get kind of the types of patterns that you see here, or if you did it without instrumenting, you would, we saw kind of from the number of inelastic demands, you might literally actually get a bunch of these to be negative, or the marginal cost to be negative. Okay, so in summary, this is basically a very powerful method that's been used a lot since. So kind of looking back, it's kind of easy to see this. And it clearly shows both the effect of instrument and the effect of random coefficients versus Logit. If you talk to people, especially kind of offline, you'd hear a lot of people love to complain about BLP, and they'll complain about the instruments. They complain about the supply side, that it's static and it wasn't tested and it's maybe driving the result. They'll talk about, well, you estimate a static demand model, but really this is all kind of a durable goods. And a lot of these things are right, and indeed follow-up work in the 20 years since have kind of looked at a lot of these issues, and we'll look at some of them further. Okay? Yes, Dan.
Have you looked to see how the BLP model would compare to, say, a nested loaded model with pre-nested?
That's exactly what I'm going to talk about in a second. Okay, and the reason the way I'm going to do this is, rather than going and trying to estimate on the original data, what I'll talk about is about the paper that came out, the same issue of Econometrica, right next to each other, by Penny Goldberg, that's going to use slightly different methodology. And I actually, part of why I pointed some of those numbers, the tables, you can actually look a little bit at the comparison. It's different data, slightly different time periods, but I think there's actually a lot to learn by just comparing them. Okay, so this is a paper by Penny Goldberg that it's a very nice paper. Actually, the application is mostly a trade application, so I'm not going to be talking about that at all, and I'm just going to focus on the demand model. So I'm really just going to talk, a tip of the iceberg, just a small part of the paper. The application is very nice, and I actually always recommend to my students to go read it, even if it's like outside the I/O course that I teach. It's actually, I think, a very nice paper, demonstrate how you'd want to present results from a structural demand model. The points I want to take away from here are two. One is I want to emphasize a point that I thought I emphasized in the previous lecture, but I just want to make sure I kind of bring it home, is the fact that even with household level data, which is what she's going to use, the problem with endogeneity, and we can see this by comparing the numbers. And then, Dan, the question that you asked about nested Logit versus random coefficients Logit, again, it's maybe not a fair comparison because a lot of moving parts here, but just to kind of compare the numbers from the two papers, we'll get some insight on that. Okay, so her demand model is a so-called nested Logit model. So she basically has this following, the following kind of decision tree, if you want. So there's a household. They decide, do I buy a car or not? Or buy at least one. If buy at least one car, do I buy a used car or a new car? If I buy a new car, which class do I buy? So think of it, which segment of the market. And if within a segment, do I buy foreign or domestic? And then once I'm kind of within this nest, which model do I buy? Okay, and the original models literally sort of show this as kind of, you can think of it as a literally a decision tree that a consumer goes through. Okay? But you don't really need to think of it this way. The way to think about this is that each of these models, so these are going to be a choice, they get an IID shock, and then there's these shocks that are at the nest level. Okay, so for example, all foreign cars in class 1 get a common shock, right? So that's going to create a correlation across these options, right? So if you don't like model 1 in this nest, it's going to create a correlation with the error term that you go, so you're more likely to go to model 2 in that nest than you are to go to another model altogether. And how important these shocks are depend on the relative variance in these shocks versus the IID shocks, right? And the idea is that there's a whole, right? There's a common shock to this nest, and there's a common shock here, and each one of these nests going upwards, okay? And one way to think about this is really what this is doing. Actually, one can even show this formally. What this is doing is really putting each of these as a characteristic, right? So whether it's foreign or domestic, or which class it is, you can think of it as putting a characteristic and then putting a very particular distribution on the random coefficient of this characteristic. Okay? It's a little bit harder to show when you have these multiple nests, but if it's just one level of a nested logit, you can actually show that that's what it is. You put a very particular distribution, and that distribution we can actually integrate out analytically to get the type of results that we saw before. Okay, the data she's going to have is household level data as opposed to the market level data, and it's going to come from the consumer expenditure survey. So she's going to use data from between 83 and 87. Overall, these are numbers reported from the paper, so overall there's over 20,000 households, 30% of which bought a new car. 30% of which bought a car, and a third of those bought a new car. Okay, so you see actually it's roughly comparable to what we had before. About 10% of households bought a car, right? That's roughly comparable to what we had before. And then here's the breakup, about 70% bought domestic and the others bought foreign. And the key is to remember, right, we're talking here, 600 observations of foreign that we're going to split now into 6 different or 9 different classes and then into different models. So by the time we're down to the model level, we're going to have a lot of models that there really no one's choosing. Okay, we're going to have sort of somewhat noisy estimates of that. The price and the characteristics are again come from this automated news market data book. Estimation. So she's going to estimate the model by maximum likelihood. Remember, this is individual level data. It ends up that there's a very simple way of estimating this model, which is basically saying what you do is you estimate which model you choose conditional on being in this nest, and then you kind of move up. You basically create, it's something that we'll see later, we'll create kind of an expected utility from this nest and then say, okay, how do I choose between these 2 nests? This is now sort of 2 options. This kind of summary is something called an exclusive value. I'll define it, in tomorrow's lecture, but it's basically kind of a very simple way of kind of estimating this at stages, and it's much. I mean, you could estimate it all in one step, but it's much easier to do it in these kind of steps. So that's what she's doing here. She's not going to directly deal with the endogeneity. And the endogeneity, remember, because this is household level data, she doesn't need to, instruments for the nonlinear parameters, right? That you can actually get from the actual demographics that she's seeing kind of in the data. She needs to literally deal with the endogeneity of price and the unobserved characteristics. So she is going to have origin and segment fixed effects. Okay, segments are these different classes, and origin is whether domestic or foreign, or I guess which country. I guess it's mainly Japan or Europe. But these are not going to fully account for the brand unobserved characteristics, right? So they will be, I don't know, kind of a German fixed effect that might affect all German cars, but there isn't something that will separate, a Volkswagen from a BMW, okay? So, she partially deals with endogeneity, but there's still, you could potentially claim that there's still some residual left over, and that's something that we're going to look at. So now let's look at kind of price elasticities by class. It's a little bit hard to exactly compare the numbers from the 2 papers because they break things up a little bit differently. But in terms of the numbers here, they generally tend to be, in terms of range, a little bit lower than what we, so I want to look at this first column, the overall elasticity, and they tend to be generally a little bit lower than what we saw before from the BLP paper. Remember, so the BLP paper was the Mazda 323, right? It had about a 6 in absolute value. Here it's about a 3, right? So here they vary from 3 and go, there's a few exceptions, but go down to about, 1 or 1.5, right? So the range in BLP was about 6 to 4. Here it's about, 1.5 to 3. Okay? Now that's consistent with the fact that there might be some residual endogeneity that we haven't, fully controlled for with the fixed effects that she has. The other thing, by the way, that you can see here of, one of the advantages of having individual level data, she can do things like giving you the elasticity for different consumer types, right? You can look at, first-time buyers versus a repeated purchase, because that's something that's in her data, right? So she can include that as a demographics and actually show you that, while doing that with the aggregate data might be a little bit hard because you need to know information on basically what I mean, it'd be very, something that'd be very hard to estimate with the aggregate data. Okay, if you look at, so that's kind of the overall elasticities. Now going back to kind of comparing nested logit versus the random coefficients. So these are again semi-elasticities. And the key thing is, and here she actually does, they did it for BLP did it for $1,000 change. She does it for a $1 change, right? So you can, need to multiply this by, instead of -7, should be -4 here to make the levels comparable. But more interesting, I think, than looking at the levels is looking at the variation within a column. Okay? So remember, what we're looking for is we want to see kind of a lot of heterogeneity in some sense, right? We want to see, big numbers here and relatively smaller numbers there. Okay? And the key is, yes, we see that pattern, but if you look, right, the difference between kind of the highest number here and the lowest number here, I mean, it's, about 15 times larger, which is, nothing to sneeze at, but it's not what we saw, in BLP we got it was, 1,000 times larger, right? I mean, 3 orders of magnitude, right? And that's a little bit, Dan, going kind of to your question, what would you get if you kind of did with the nested logit? It sort of looks like, it is picking up the patterns that you see kind of bunching up, the products, but in some sense, maybe it's not doing enough of that, right? Because you kind of ask, and again, I don't know what the level here should be, so just ignore this, but you can ask, if a Civic changes its prices, how many people are going to switch to a Ferrari? I mean, well, you could say this is 0, right? But I'm saying it's relative to, switching to Tercel or something like that, right? So I would have actually expected the ratios more like what you see in BLP. Now, is this driven directly by the nested logit? I think so. I think that you just need to have kind of more characteristics in some sense here to really pick this up. But again, to really sort of see this, you would have wanted to go and say, well, what if we actually did the BLP with, with their data, with the aggregate model? Oh, of course you are. I mean, you're basically saying they're a function of the characteristics. But I'm saying here I've taken sort of 2 studies that do different approaches, and I'm just looking at the outcome. And what I'm saying is, I don't know, again, as a non-expert of the car, of the auto market, seems to me that I would have expected a higher ratio here than what I actually see. That's all. Now, if someone knows more about cars and tells me, oh, no, this should be sort of higher, I'm kind of willing to step back, say that, but it does seem to me like I would have expected, the ratio here to be higher. Maybe. Yep. So as opposed to the difference here in the own elasticities, I am pinning on the endogeneity, okay, on the fact that there's no constant option-specific constant. Here, it's so endogeneity would impact the level of these. It's not clear how endogeneity should impact the relative magnitude. Okay? And again, you can sort of formally go and try to kind of derive this, but that's why I'm saying I'm not necessarily looking at the levels, because the levels here are actually lower than they are before, and partly because they're doing the not comparable, but even if you multiply this by 1,000, it's still lower than what we saw before, right? So the level could be, for anyone, could be, but I don't think that endogeneity could explain or be the main cause for the relative difference between, within a column, right? So the ratios, and that's what I'm focusing on. Okay. Ariel, did you want to? Well, it is, except that the specification you used, if you had the class and origin variables in there, then I agree. Yeah. If you have the same characteristic, I completely agree. Yeah. No, nested logit, I mean, I kind of mentioned this before, but just to emphasize, nested logit is a random coefficients model with the characteristics being the segment dummies and a very particular distribution on them. Okay? There's actually, you can formally show that. There's a paper, Cardell. No, I know for sure it's exact in a one-level nested. I assume it could be extended further, but it's exact. You put a very particular distribution on it. Okay, it's not a normal distribution on the random coefficient. It's a very particular distribution on it, and you can show that it's exactly the same. So, so people say, oh, nested logit is not. Nested logit is a random coefficients model, but a very particular distribution. Okay, and the characteristics are the, whatever it is that used to define the segments. Okay. Yes, Chris.
The third difference is that this uses the actual transaction prices, whereas the BLP uses the list prices. Have you thought through what?
I haven't, and partly because I'm not exactly sure what she did for the prices of the options that were not chosen. So you have the transaction price for what you bought, but then I don't know what the prices are for the options you didn't buy. So I don't actually know. I have to go back, but it's been a while since I've looked. I don't actually remember what exactly she used for the price. Some follow-up papers have actually claimed, I don't know this literature as well, but I know, for example, in consumer packaged goods where there's coupons, some people have actually argued that even if if I know that you bought something with a coupon, but I don't know if you would have used a coupon for another product that you didn't buy, that you're actually better off ignoring the coupon, which the equivalent here would be that you might be better off just using list prices. But it really depends on it's, in some sense, you're going to have a problem either way. So I don't actually remember what she actually did. That's a good question. I should know, but I don't remember what she actually did in terms of getting the prices for the other options. Okay. Now, in terms of markups, I think that's kind of reflected in the numbers. So if you actually look at either price minus cost or the markups that she gets, she generally actually gets markups higher than BLP. And actually, even if you read Penny's own paper, she actually kind of admits, she says, well, 50% is kind of the perceived wisdom of what the average markup would be, and I'm actually getting something a little bit higher. Okay, and she has some discussion on it, and you can see, she's maybe doing kind of all right, kind of at the lower end of the distribution. I'm not quite sure how this accord suddenly gets, 10%, but otherwise you can see it's kind of monotonically, only with that exception, kind of increasing and getting actually at some point to pretty high markups. And I think kind of higher than what people believe are reasonable. This, although, frankly, I have no idea what the markup should be on Ferrari and Porsche. It's beyond my range. So, okay, so this is again consistent with the numbers of the fact that maybe even though she's included all these characteristics, sort of these dummy variables, there's still some potential for kind of leftover endogeneity, even though she's using individual level data. Okay, that's yeah. Okay. Any questions, comments?
Is the higher markups, high price model, is that for small scale and big fixed costs of running a model? Is that the market equilibrium?
Oh no, what's writing this here is she's basically, what she does is she computes the demand elasticities, then she puts it through an Ash-Bertrand pricing model, right, and compute the markup. So if your elasticity was low, you're going to get a very high markup, right? So low elasticity means people are very price sensitive, and therefore the markup would be higher, right? So this is not necessarily coming out of any cost data estimation. It's really just, from basically taking the estimates. We'll actually show you the equations in a few more slides for a different context, but it's kind of taking the demand estimates and plugging them in. Yeah, yeah. Mark?
With the micro level data, you could estimate different things in terms of the consumer attributes. It seems like, given the estimation methods, if you had the same data, just one at the market level, the other one at the individual level, you would still be estimating the same effect. You might get different coefficients on them.
So,
Is there anything that...
So you're saying if we had...
the same data, one that was just at the market level, the other one at the individual level, is there anything more that you can do with those data two coefficients?
So I think the answer is yes, right? Because suppose, for example, we had, in the the BLP data, we had the fraction every year of new buyers. Just that. We wouldn't know what they bought. We just know every year what fraction of the people. So that would be a demographic, right? Where we'd know, the distribution. Now, if there's a lot of variation over time in it, you could, with aggregate data, try to estimate, the new versus repeated buyers, right? I mean, that was the one demographic I talked. But if there isn't, that's going to be very hard to pick up. So I think if you really care about that, the effect of observed demographics, I personally would put a lot more. So if I actually get different numbers from aggregate data and from individual data, I trust individual data more there, just because it's, you really see, here are new buyers and here are old one, and repeated buyers, and I see the different purchases. While in the aggregate data, you're really working off, some kind of variation in the market, and unless you have a lot of markets and a lot of variation, or you have some additional information of saying, it's not just, the fraction, I also know which cars they bought, something like that. So if you have these additional so-called micro moments, I would believe them. But otherwise, I really would believe more the micro data. The other place where the micro data, and we'll see that later tomorrow, is if you want to go to dynamics, right? You could estimate dynamics with aggregate data, but it gets, I'd feel a lot more comfortable if you actually see households and you see, let's say, for example, how long they've held on to their cars or what other cars they have, if that's the thing that you want to estimate, if you actually have individual level data as opposed to try to simulate it through some aggregate.
What about the correlation between the two? So if you have the individual data, you can see that low-income consumers are more likely to, for example, buy the used cars. In the market aggregate, you would just see the percentage for both. Does that correlation enter into the...
And what we've done up to now, no, but that's extremely useful. So, when we talked about, different ways to kind of get more variation, and that's one of the things we're going to talk about. I forget if it's this afternoon's lecture or tomorrow's lecture, but we'll talk about bringing in this additional information. So, for example, Emil Petrin, in his study kind of the auto car, that's what he did. He brought in this additional kind of what we call micro moments, and that was extremely helpful in pinning that down. So whenever possible, so if there's kind of, if you want to quick bomb, whenever possible, if there's any information you can get from micro data and incorporate that into the analysis, it definitely should be. So I hope that the message that comes away from this, I hope, is not anti-micro data, because then I totally screwed up. That's not what I wanted to say. Quite the opposite. I'm just saying whenever you have micro data, being able to incorporate it into analysis is extremely useful. But you have to be aware that even with micro data, there's potentially additional endogeneity, and you want to take that into account. So it's not against using it, quite the opposite. If you can, use it. And indeed, Petrin was one example of saying, let's bring this kind of CX type information into a BLP world, and it ended up being extremely powerful and extremely useful, and allow it actually relax some of the assumptions on the supply side. And we'll talk about that next. So that's very, very important. So I hope I didn't come across as anti-micro data, because that's exactly the wrong message. It's, okay. Any other questions, comments? So let me, let's see, we started at 1:30, so we're planning to go till 3. Let me, I was debating whether to stop here or to continue in this page. So let me kind of continue. I think I can do this in 20 minutes. And let me talk about kind of the last paper, and again, sort of see a little bit of a different takeaway. So this is my own paper. And the points I'd like to sort of take away from this, I guess there are several. First is the, so people have often said, well, okay, these characteristics models, they work great when you're doing autos because the characteristics are obvious, but how would you do it in the case of, products that characteristics are less obvious? So I think Jerry Hausman is actually on record in writing saying, oh, you could never do this for cereal. Or, how would you ever do it for champagne? Would you measure the number of bubbles, how fast they go up and stuff like that? So that's part of, what you kind of try to do here is to actually show how you can incorporate, when characteristics are less obvious. The other thing is, we talked about different instruments, so I kind of like to show you here the different effects and kind of maybe explore the different instruments and how they enter. It's a question of testing the model of competition, because obviously that kind of enters a lot, and that's going to be here as well. And then finally, we're not going to do it today, but next time, kind of first thing tomorrow morning, we'll actually talk about alternative methods. So just like I did comparing the BLP and Goldberg, I'll actually compare this to kind of an alternative method, in that case, the multi-stage budgeting numbers, just to kind of get some idea of the differences between them. Okay, so serial, you have the unfortunate case where I actually know more about serial than about cars, so I'm going to bore you with a whole bunch of facts just because I had them easy. But anyway, so serial is actually characterized, at least at the time, as a fairly highly concentrated industry. The top 6 firms had about 60%. By the way, since then, there's about top 4. So there's been a couple of mergers in here. They had fairly high price-cost margins and large advertising to sales ratio, and also a lot of introduction of new goods. So this has always kind of been used to claim that this is a perfect example of an industry where pricing is roughly collusive and firms compete on other dimensions. Okay, so they compete basically sort of through advertising, through introduction of new goods. So that's kind of, there's always a textbook example of that. So the questions that I kind of went out to answer was to ask, is really the pricing in this industry collusive? Or another way of saying it is saying, okay, the price-cost margins are high. We'll take that as given. But the question, how much of this is due to product differentiation? The fact that, we might think, if you don't eat cereal, you might think all cereals are alike. But, people who eat cereal might actually disagree. So how much is coming from that? How much is coming from the fact that these are multi-product firms that have a portfolio of products and therefore take that into account in their pricing? And then how much of the rest, if you want, is price collusion? So the way to kind of address this, and this is if you want kind of just as a general example of how to use these types of demand estimates to kind of answer other questions, or even if you're not interested in demand per se. So the way to do this is, estimate brand level demand, and we'll focus on that. Then compute price-cost margins predicted by different industry structures and different models of conduct. And I'll show you in a second what I mean by that. And then compare those to some sort of kind of industry knowledge or feeling about what the markups are. Yes?
You know a lot about cereal. Cereal question.
I should have said I knew a lot about cereal.
Okay. Well, so in the last 10 years, most of the major supermarket chains introduced generic cereal
Mm-hmm.
the brand
Mm-hmm.
cereal. And I was wondering how you think about ad entry by firms who are not necessarily optimizing over just that good. So, for example, like Giant has sort of coffee, special K right there,
Yep.
but they may be more interested in getting you into their store to buy other more high margin items. And so I was wondering if this were, if you was possible to think about that in this context,
Yes, it's going to be a little bit more complicated on the supply side, but you could deal with it with, if you're willing to put, some structure or some assumptions. But we'll see on the demand side, it's actually quite natural to add that. And indeed, if you want to highlight the importance, for example, of XI in this context, that's going to be extra important, because what you're going to get is you're going to get 2 products, the national brand, the generic brands, that, have practically the same characteristics. Right? So first we'll see how we'll find characteristics, but there's going to be 0 variation in them. But yet if you look at the prices, right, the national brand is, depending on the product, sometimes it's, twice as expensive as the generic, as the store label. And if you don't account for that, that's going to create a very severe endogeneity problem, right? Of sort of, here's the national brand with high prices and high shares, and the generic with low prices and low shares. Right? So on the demand side, it's very important to include that. And it's not just by saying, oh, let's just have one of the characteristics, whether you're national or generic, because the relative how good the generic is really varies. So for example, cornflakes is one of those products that's very easy to imitate. And indeed, they've lost a lot of market share, well, for a bunch of reasons, but that's one of them. Cheerios, on the other hand, is very, very hard to imitate. Many people have tried, including Kellogg. They had a cereal it was introduced in 1959 that survived for 10 years. It was called OK. Okay, O's and K's. Well, terrible marketing name, and it's like, yeah, I really want to buy something that's okay. Yay. And indeed, so they tried, and there's actually I don't know if this is true, but Frank Fisher told me, so I'll assume it's sort of true. But he said that Kellogg at some point tried to figure out why the cereal wasn't selling, and they did these consumer panel tasting, and the guy said, this tastes okay, but this other cereal is kind of lacking kind of this slight metallic aftertaste that we feel in Cheerios, and that's why they didn't buy. It was, but anyway, so. Yeah, we can talk a little bit about that. I mean, it's not really the focus of what we're doing here. So even though I have supply on here, but that's, I think, the first. So we can introduce this, but maybe we can talk a little bit about that later, just because it doesn't directly fit into anything that we talked about. But in principle, I think there are ways that you can introduce it. Okay, and we can talk about about how. Let me just, these are supply equations I've kind of hinted to before. Let me just sort of go through it. So the profits of the firm are basically the variable profit minus the fixed costs, and these kind of become the first order conditions. And what's very useful is to actually write these first order conditions in this matrix format, where each element of the matrix is either this cross price derivative, or the derivative of the demand function, or zero. And whether it's zero or not depends as to the quote-unquote ownership structure. So if we have single product firms, this is going to be basically a diagonal matrix, right, with just own price effects and diagonal, zero elsewhere. If it's multi-product firms, it's going to be kind of blocks. And if you think of a monopoly maximizing joint profits over the whole industry, it's just going to be a full matrix, right? And that's kind of when we talked about before looking at different structures, that's in the sense in which the different structures enter. It's basically what's kind of zeros or not. But with that in mind, you can basically say these are the first order conditions, and in principle what they mean is that the markup is just equal to this matrix, which is a function of demand derivatives and the ownership and and the market shares, right? So the basic idea, and this was kind of implicitly used in the tables that we saw before, what it basically says is if you have the demand estimates, right, which enter into this matrix, right, that's these derivatives, right, so the price sensitivity, if if you have that and you see the shares, right, or you have the prediction shares, you can compute what the markups are without observing cost data, right? And we kind of got into this in some sense backwards, but if you look at how did I/O people get interested in demand, it's because of this, right? It's because we said we don't actually have good cost data, and we want to know what the markups are, right? So that's kind of what we're doing here. Okay, so that's kind of the basic idea, is to say let's estimate the demand, plug it in for different equations, see what the markups are, and see which one fits better. So the utility is basically as before. Really, the only difference here is that part of the characteristics are going to be brand dummy variables. So there's going to be a dummy variable for Cheerios and for cornflakes, stuff like that, to soak up some of this variation here, right? So it's soaking up, all the quality that's constant over time, right? So to the extent that, Cheerios, its characteristics, and what's more important than characteristics, the way consumers perceive them, whatever is constant over time is picked up by this, by these brand characteristics. There is a bit of an issue of then how do you get the coefficients here on characteristics themselves don't vary over time, and if I have time, I'll talk about that, but it's kind of this kind of second stage regression that you can get that. So the data that comes from, that's been used here is the IRI scanner data. So these are data that come from basically supermarkets. Supermarket report, to IRI. So IRI and Nielsen are these two companies that collect these from supermarkets, and they kind of aggregate this and then report it back to some of the companies. Here, what I had was so the data, the original data is actually collected at a UPC, at a barcode level, at a supermarket at a week. Here, what I had was at the brand level, so it was Cheerios, all the different barcodes of Cheerios aggregated together. at the level of MSA, so aggregated quite a few stores, and aggregated to a quarter, so over 13 weeks. So what I had here was basically the top 25 brands in 67 cities, where the exact number of cities varied over time, over 20 quarters, and got about 28,000 observations. The market shares here, right, to convert quantity to shares, I did that by essentially looking for each of these products. I had the volume, converting that to number of servings, and then assuming that each person in each city is going to consume at most 1 serving per day. Okay, so that was the total market size, and then that's how it was converted into market shares. And the prices are defined as here. It's pre-coupon transaction prices. Anyway, a whole bunch of other variables. By the way, you asked before about cost instruments. So, apparently I got them from the monthly CPS. That was, we'll talk about that later. Okay, estimation basically follows the method we talked about before, only demand side moments, no supply side moment. So really here the extra variation is there's going to be over 1,100 different markets, okay, where the markets here vary both by time and cross-sectional. There's 67 different cities, and that's going to be quite important to create the variation we need to estimate the random coefficients. So I've explored various instruments here. The characteristics of competition, right, what we, the first set of instruments we talked is actually problematic here because we have brand fixed effects and the characteristics don't change, almost kind of by construction. So what I'm going to use is the prices in other cities that we talked about before. I also compare them to kind of proxies for city level cost. Kind of these are kind of earnings in the retail sector, density of the city, trying to get for the rental cost of, and maybe transportation cost. But I really only do that, for the logit model. Let me skip kind of the brand fixed effect. So let me show you some estimates for the logit model. So one thing that I do find useful in doing is to always start with the logit model, just to get a feel for the data. And feel of what's the variation that's driving things. Just because, these are linear regressions. They're very easy to do, right? Unlike everything else that takes time to program. This is once you have the data and it's organized. It's an afternoon playing around with data, even if you have a very large database. So it's always a good idea to kind of get what's going on. So these are all logit numbers, and I'm just going to focus on the price coefficient. This directly translates into elasticities, but I'm not going to show you what those are. So just to kind of get the idea of the endogeneity, so the first column doesn't include any brand dummies. And then the next column includes that. It's still OLS, but just putting in brand dummies to capture, the kind of the mean differences. And you see, as we saw kind of in BLP when we instrumented, same thing here. The price coefficient, significantly increases, right? And it's kind of linear in the elasticity, right? So the elasticity is not quite doubles, but almost, I don't know, it's about 50% higher, okay, in absolute value. And this is the same thing, just kind of adding a few more demographics. They don't do much. Okay, so these are all OLS, now kind of putting in various IVs. So the first thing here is I actually use IVs. So instead of including IVs in the regression, what I do is I use them as instruments, right? So the idea is to think of it, it's kind of a non-parametric version of the characteristics of other products, because the characteristics of other products are constant, right? So think of it as if I included, 25 different interactions of these, right? So it's kind of think of it as a non-parametric version of that. And what's interesting is you actually you get very similar, it's comparable to these, so very similar numbers whether you use these as instruments or include them. So in some sense, it's sort of saying that, this is potentially a pretty good instrument to use for, if you're worried about this kind of unobserved quality, it actually potentially could work reasonably well. The rest of these columns, what they do is the brand fixed effects are back in there, and now I'm worried about the endogeneity, not just of the average quality, but of the deviation, market by market. So the thing that you can think of is that this is like some sort of unobserved promotional activity that's going to impact the specific shares in any particular market, and you want to instrument for that. And the different columns, what they do is they either what I call prices, so that's the price in another city, or these cost proxies. And what I find quite interesting kind of looking at this is the fact that they move in tandem, right, depending on what else I control, but they're almost identical, these two different sets of instruments, and in some sense, have no reason why they would produce, right, if they're completely different where they're coming from, yet seem to actually produce very similar numbers, right? So going back, we had a lot of doubts of, whether these instruments work, but, to me this was actually, yeah, I can tell the theory story, but it actually seemed to work reasonably well when you move together. So when going to the nonlinear models, I only used the prices in other cities, because these, in some sense, I didn't have enough of them, but it's just a way to feel better about these prices in other cities. So these are estimates from the demand model. Let me skip that. I don't know that there's anything particular interesting here. So these are cross-price effects. So these are actually elasticities, not semi-elasticities. Let's see if I can actually, oh, yeah. So I increased that a little bit, so I don't know if, can you see any of these numbers, or is it totally, yeah. Okay, so again, how do we look at these? Well, I think it is, always useful to look at. The first thing I look at is, if this was a logit model, within column, this should just be a single number. Okay, and I think actually in the paper I even report, I don't remember what that number is. So the thing that you look is to see how much variation do I see in that. I mean, just plain, is there any variation? And then does that variation make sense? Okay, does it end up, that the cross-price elasticity makes sense? So for example, if I'm looking at cornflakes, it looks like its closest substitute is Wheaties. Okay, which makes sense, at least, to some extent. And then frosted flakes, right, which are basically just cornflakes with sugar on them. Okay, it makes sense. Another thing to look at is, and this is actually going to be important when I look at tomorrow. So let's see here if I can fit them all. So I'm looking at post-Raisin Bran, and which one is the Kellogg Raisin Bran? Just a second. It's the second one, okay? So I'm looking at the post-Raisin Bran column, okay, where, right here, okay? And what's its closest substitute? It's, Kellogg Raisin Bran. Okay, now, if I'm looking here at ratios, would have I liked that margin, that it would have been higher? Yes, but at least, it is coming out as the most, as kind of the best, whatever, the closest substitute. Now, of course, how close, if I really cared about that, I maybe could have put in, raisins as a characteristic. Okay, but it wasn't in here. I can show you what the characteristics were. Right, so the characteristics are the ones that I had here. As you can actually see, there's calories from fat, sugar, a dummy variable defined as mushy, and that's whether the cereal actually gets moist, basically whether it's a flake or not. Right, it's and then the amount of fiber, and then these are segment dummies. So very much like if you want the information that you would get in nested logit, but segment dummies, and just put like a normal distribution along them. Right, so there's nothing here that will obviously sort of tell you, oh, it's pushing these two kind of rigging the game to make sure that they're the same. But you see, it's still enough to actually pick up that those are the closest substitute. Okay, and then you can compute the margins here, and here they're under different models, and then how do you choose between them? Well, you go to some data, and it ends up the industry estimate was 45, and that's basically the only model that fits is the model here without collusion. So that's the one that I went with. Let me just, I'm basically out of time, but this is my last slide. Let me just sort of talk about, some comments and issues, and kind of build up on, some of the issues that came up and the people asked me. So one of the issues that always comes up in this context is asking, is choice really discrete, right? So we assume you only choose one cereal, right? And you could always sort of say, in all of these settings, it's like, well, we say it's a discrete choice, but is it really the case? So there's two ways about this. One is to say, well, let's just define the choice finely enough. So it's like, yes, consumers can buy multiple boxes when they go to the store, but the question is, when you wake up in the morning, are you going to sort of take, I'm going to take a little bit of cornflakes, a little bit of Raisin Bran, and mix them in the bowl, or you just say, I'm just going to take one, right? So you could sort of say, if you define the choices every day, I'm going to choose what it is. So this is an approximation to this two-stage process. First, I decide what to buy, and then what to put in the bowl. But if you really care, you think that in some cases that's not a good fit, there are extensions that we're not going to have time to talk about. Most notable, I think, is actually a paper by my colleague Yigal Hendel. We actually modeled the multiple discreteness, both in terms of choosing multiple brands, but also choosing more than one, right? Of saying, I'm not just going to buy, in his case, he looked at PCs, firms deciding which PCs to buy, not just, one PC, but how many, right? So kind of ignoring both that. So there has been some work that we're not going to be talking about. The other thing here is it ignores the retailer, right? This was basic manufacturer. So probably say, well, where's all the retailer in this? Well, again, you can extend the analysis. So this paper by Sofia Villas-Boas does exactly that, and there's been a lot of other work, John Asker, and looking at other industries. There's a lot of people that have followed up looking at the vertical relations, following up on this. And then the other thing that I just want to set up for kind of my last lecture of tomorrow, you might ask, well, cereal is a storable good. How much of the price, or where's the price variation coming from, and how much of the price variation is from sales? Kind of these temporary price reduction, and how does that impact the estimation? Okay, so what happens, this is a static demand, but you say, suppose it really what happens, there's kind of dynamics because of the storability. How is that going to impact? And that's something, again, that we're going to talk about tomorrow. Okay? Any final questions?